So here the question is, derive an expression for kinetic energy of a rotating body, or you can say derive kinetic energy of half I omega square. So here I stands for moment of inertia and omega stands for angular velocity. So this question is very important for boards, 12th boards. So we are going to prove kinetic energy is equals to half I omega square. So for that we need to draw a diagram. So we have considered a rotating rigid body. So this is a rigid body. Suppose body is made from n number of particles. So as we have considered, this is a rigid body, so here the body consists of n number of particles. So it has mass m1 m2 till mn. So here the mass of this particle is m1, this particle is m2, so and so on till mn, mass, n number of masses. So they are situated at the distance of r1, r2 and rn from the axis, center of the axis. So yes, rn respectively from axis of the rotation. So now we will consider omega. Yes, we know that omega is angular velocity and E stands for kinetic energy for a particle having mass m1. So for the particle of mass m1, kinetic energy we have considered as E. So we know that E is equals to half mv square and velocity v is equals to r omega. So we have considered v1 is equals to r1 omega and kinetic energy E is equals to half mv square. So we will consider for first particle, that is E1 is equals to half m1 v1 square, E2 is equals to half m2 r2 omega square. So here r1 omega square, in case of v1 we have written as r1 omega square, as v1 is equals to r1 omega. So in case of v1 we have written r1 omega square. So till en is equals to half mn rn square omega square. So total kinetic energy here comes E total is equals to E1 plus E2 till En. So we will write the values of kinetic energies, that is half m1 r1 omega square plus half m2 r2 square omega square plus and so on till a half mn rn square omega square. So we will take half and omega square common and we will write m1 r1 square plus m2 r2 square plus and so on till mn rn square. We know that this summation of m1 r1 square till mn rn square is inertia. So we have written this expression we have shortly written as like this, so which is nothing but moment of inertia. So therefore instead of this we can write it as, so I will write it here, E is equals to this half, we will write it like this, half I omega square, which we have proved. This is given in the question. So now I'm going to tell the extra thing, which is we are going to multiply and divide by I. Then kinetic energy E comes to be I square omega square upon 2I, and we know that L is equals to I omega. So we can write I square omega square as L square. So therefore the expression comes to be L square E kinetic energy E is equals to L square upon 2I, where L is angular momentum. So this L is angular momentum.